Dear students, I am Sanathan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain about how to make your own solar cooker and how to find the focal length of a mirror experimentally. Now listen. So these are the diagrams. Already I draw the diagrams on the blackboard to reduce the time. And allotted the more time for explanation purpose only. So how to make your own solar cooker? That is one. That's why if you can do this thing, you must be want some metals are required to us. Dish TV antenna, ruler, acrylic sheets, black suited vessel. These are the important materials are required to this one. So we know that generally in our houses in the nowadays most of the people are using dish TVs instead of box TVs. Airtel digital TV, Sun Direct, DTH means dish TV, Videocon, Reliance, Big TV, like this type of one. So in this one, those the people are using that one. On the terrace of their houses, we are observing that one concave shape of the dish TV antenna is there. That is the dish TV antenna. It is which shape? Concave shape. This is the shape of the antenna. So the reflecting surface is inward. That's why it is which shape of the antenna? It will be concave shape of the dish TV antenna only. That's why. So first of all, we can take a dish TV antenna and measure its focal length. And you can find its focal length. How we can find the focal length? That's why I will tell the simplest way to you. In what way we can find its focal length means. So is any person is using the which one? So dish TV antenna. In the dish TV antenna, one receiver is there, receiver point. Receiver point is exactly placed where at the focal length of the concave and surface of the antenna. That's why. So before place the vessel at the focal length of this one. First, what you can do after taking the dish TV antenna, with the reference with help of the another dish TV antenna. By using the ruler, we can measure the distance from inner part of the depth to receiver. That is gives the focal length. That's why exactly what is the focal length is there exactly at the distance from this one. We fixed a black suited vessel. So dish TV antenna we can take it and with help of the ruler already we find the focal length. That focal exactly at the focal length point we place a black suited vessel with help of the support. Why we can take the black suited vessel? Black body acts as a good observer and good emitter. That's why when 100% of light energy will be fall on it or heat energy, it absorbs the nearly 99% and 98% is transferred to other side. That's why it is a good observer and good emitter. Then, so what is the energy will fall on it? Most of the cases, nearly total energy will be absorbed. After observing, that energy will be imparted to the inside the vessel. That's why we can use the which one? Black suited vessel. After that, now so the concave surface of the dish TV antenna is covered with acrylic sheets. So first of all, we can take the dish TV antenna and find its focal length. At the focal length, we place a vessel. Now we can take the acrylic sheets. It will be cut into the triangular shape and it will be fixed at the concave shape of the dish TV antenna. And after that, now it will be keep into the open place under the abundant sunlight, opposite to the sunlight. So we know that the sun is 150 crore kilometers from the earth. That's why the sun position is appears infinite distance from the concave shape of the dish TV antenna. But here, why we are using the acrylic sheets? Acrylic sheets will act as a good reflectors because of it is appear like a small mirrors. That's why when the light will be fall on it, so it will reflect it back most of the light. That's why the rays are coming from the sun. This one you are observing that the rays are coming from the sun is just like appears as parallel to the principal axis. That's why after fall onto this concave surface, After the reflection, every rays will be exactly meet at which point? Focus only. At the focus already we place which one? A vessel. That's why the vessel will be absorbed huge amount of heat energy. That heat energy will be imparted to the things which are used inside, then they will be cooked very easily. And with help of the solar cooker, we can achieve nearly 547 degree Celsius temperature. That's why the vegetables or water which is used to heat, they are quickly boiled or cooked. How to find focal length of a mirror? Experimentally. So what are the materials are required to find the focal length of a mirror experimentally? Means a V-shaped stand, a concave mirror, a candle, a ruler, a table, and a screen is nothing but a white paper or white cloth we consider as a screen according to this one. So listen very carefully here. Okay. It is a V-shaped stand. It is a concave mirror. It is a work screen. It is the illuminated candle, means lighted candle. It is the table. First of all, a concave mirror is placed on a V-shaped stand, or a concave mirror is fixed, keep in a V-shaped stand, and further it is placed on the horizontal surface of the table at one side. Now we can take one illuminated candle. Illuminated candle is placed in other side of the concave mirror or V-shaped stand. Now we can take a screen. The screen is placed between the candle and mirror or V-shaped stand. Now you are slowly move the or gradually move the V-shaped stand or concave mirror towards the object or towards the illuminated candle or away from the illuminated candle up to, means until you get a clear image on the screen. Why? Because we know that concave mirror is forms real and virtual images. But if the object is except it will be lies between principal focus and pole of the mirror. Remaining any cases it will be forms the real image. Real image is always we can caught on the screen. That's why what we can do here. So illuminated candle is there. The candle will be appears certain long distance is there. That's why the rays are coming from the candle. After fall onto the concave mirror by the laws of reflection, the reflected ray will move into the another direction. In the direction of the reflected rays, we place the screen. On the screen, we get a image. But if initially, so we are not observing the clear image, then what we can do? Now we can adjust the length. Means now we can move the concave mirror towards the candle or away from the candle until you get a clear image on that one. After that, with help of the ruler, now we can measure the distance from V-shaped stand to candle. It gives the object distance because of candle is the object. V-shaped stand, in the V-shaped stand we place it on concave mirror. That's why it is the pole of the mirror, means exactly midpoint. So the distance from V-shaped stand to candle is gives the object distance, and the distance from V-shaped stand to screen is gives the image. Why? Because of on the screen which is from image. Now this U and V values is substituted in the mirror formula. That is, we know that 1 upon F is equals to 1 upon V plus 1 upon U. So U and V values substituted in this formula. Do you can find focal length or not? Yes, we can find the focal length. One second, listen. So some methods are required to find the focal length of a mirror experimentally. V-shaped stand, concave mirror, a root candle, ruler, table, and a screen. These are the methods are required to us. So take a concave mirror, it is kept into the V-shaped stand. Further, it is placed on the horizontal surface of the table at one side. Now we can take one illuminated candle. The illuminated candle is placed in front of the V-shaped stand in another side. Now we can take a screen. The screen is placed between the V-shaped stand, means between the mirror and candle. Now we can slowly adjust or move the mirror towards the candle or away from the candle until you get a clear image on the screen. When you observe or when you get a clear image on the screen, at that time now we can measure the distance from V-shaped stand to candle. It gives the object distance, and the distance from V-shaped stand to screen is gives the image distance. These two values are substituted in the mirror formula. Then you can find the focal length of the mirror experimentally. So this is the brief idea about. But this question is very important for exam point of view in formative assessment or summative assessment when the chapter is in the case. So now our chapter is completed. Thank you.